Let me welcome you SIAM NPTEL online certification course of network analysis for mines and mineral engineering. This is the lecture 5 and in this lecture we will discuss the rules of dummy jobs, redundancy and cycles. So, before that let us retrospect what we have covered so far. At this point I believe you have already observed the lecture 1, 2, 3, 4 and from that now you are accustomed with the activity on network on nodes network diagrams. You also accustomed with the activity on arrow diagrams and you know what is called network, how the jobs are identified and all these details are known to you. And also in the last class we have discussed that how the dummy jobs are required in the activity on arrow diagram to plot the network for the understanding of the user to identify which are the predecessors and the successors jobs for a particular job. But to cater that problem, activity on node diagram is much easier, where the jobs are identified in the node and thus the predecessors and successors can be easily connected with the arrows from one node to another node. Where arrow activity on arrow diagram, their nodes are only for the showing the initiating and the terminating point, and that is why arrows are basically depicting the jobs. So, this so far we have accustomed with all these things, and in the last class we concluded with a big network jobs and activities table was given to you, and I asked you to try to solve that in your house by your own. I believe that civil engineering problem has been solved by you by yourself, and I show you once the solution of that one. This is the solution of that one. Now I am showing you, and this problem is also available in the West and Levy's book. You can follow the same for getting the details of that one. So, this is the activity on node diagram for the solution of that problem, and the next one is the activity on arrow diagram, and you can see you need to use some dummy jobs. You need to use some dummy jobs in this activity on arrow diagram. So, these dummy jobs are there, but in activity on node diagram that is not required. So, unfortunately, instead of the dotted line I forgot it. So, it is showing in a color line, but these are the dummy jobs. So, but the general understanding is that dummy jobs has to be mentioned in a dotted line, and you last time also in last lecture I have also mentioned it. So, you do not forget to put the arrow. Arrow is very important, which shows the direction of the flow of the jobs. So, that is very important. You never forget to use the arrow while you are giving the idea about the networks. So, now in this lecture we will discuss about the dummy jobs. First, that means we will consider only the arrow diagram, that is the activity on arrow diagram, because dummy jobs are required in the activity on arrow diagram. So, we will try to understand how the dummy jobs can be placed, or while a complex network is given, a number of jobs has to be placed in that network. In those conditions, how the dummy jobs can be assigned judicially, so that can be addressed. Now, for that we let us understand the rules for dummy jobs. So, you can see the first requirement is that it is advised to make liberal use of the dummy jobs when we start the diagram for constructing the network at the very beginning. That means, so suppose it is mentioned to us that job A is the predecessors, only predecessors of the job B, but instead of placing a node here, so that can be shows like that A is the predecessors of job B, let us first separated all the jobs with the initial and terminal nodes and connect them with the dummy activities, let us say A1. So, that is the essential requirement in the initiation where initial point when we are trying to draw the network, because in a complex structure we do not know. Now, we are observing only job A and job B, maybe there are job T, job U, job V, all those jobs are there. Some of them may be having the predecessors of A, which is not known to us at this present point. So, initially when we are constructing like this, A is here, B is another one which are connected by a, B is another one which is connected by a dummy job at this point. So, this is the essentially we are carrying out this wholehearted or wholesome way, we are providing the dummy jobs by placing in every actual jobs individually and we connect them with the dummy jobs, and later on we remove those dummy jobs because these are more number of dummy jobs are assigned in the network. So, let us see the first rule. The first rule is that if a dummy job is the only job emanating from its initial node, it can be removed. So, if you see this activities, in this activity you can see the first job A here, second job E is here, and the B, C and D, these three jobs are having predecessors A and B is having another predecessors E. So, we can draw the table is like this: A, B, C, D, E, where A is having predecessors none, B is having predecessors A and E, C is having predecessors A, D is having predecessors A and E is having predecessors none. So, we are trying to construct this one, and by that way, as we have individually distributed those each and every activities. So, this is the activity E and A placed here, B, C, D are placed here, and the dummy activities A1, A2, A3 are assigned to B, C, D to show their dependency on the A as their predecessors, and also the E1 dummy job is assigned here to show the dependency of B as the predecessors on A on E. So, this is the way it is distributed, but we feel the more number of dummies are assigned. So, we need to reduce some dummies from that diagram. For that, what the rules we are following? The first rule is the dummy job which are only job emanating from its initial node can be removed, and that is why the E1 dummy job is removed and we directly connect the E to the job B as its immediate predecessors. Now, see the rule number 2, which is telling that a dummy job, if it is the only job going into its final node, it can be removed. So, that means the for C and D, the dummy jobs provided A2 and A3 are the only jobs which are having the final node reaching at the C and D, and that is the only node reaching at the C. So, C and D, that is why we remove those dummy jobs and we can directly connect C and D job with the final node of the A. So, that is why by this way we are able to remove A2 and A3 jobs, because that is, if we are removing that one, then also the outcome of the complete network will remain same, but the analysis time given to the computer will be much less as we are earlier computer need to analysis for 3 more dummy jobs, which is not required at this stage. Let us look into the other rules. The rule number 3 says, if jobs have identical sets of predecessors, some of which also appear in different sets of other jobs, then the 2 jobs should emanate from a single node connected to their predecessors by a dummy job. That means, if there are number of dummy jobs which are common predecessors for the some successive jobs, in that case that can be connected to a common node which can be connected as the predecessors of those jobs can be used, and by that way we can eliminate a number of dummy jobs. Let us look into the details of this one. Say we are having a network like this, where 2 jobs A and B, if we construct the table, we will say it is like this: A, B, C, D. Sorry, let me do it once more. A, B. So, this is A, B, C, D, E and F. And if we see, there is no predecessors for A, there is no predecessors for B, C is having predecessors both A and B, D is having predecessors both A and B, E is having predecessors A, and say another one is available. Let us put the value P, say let A and P, and F is having predecessors A, let me rub it once. Say B, and let us term it as Q. So, this one is Q, and this is the predecessors table provided to us, and initially when we are placing, we have used all these dummy jobs A1, A2, A3, B1, B2, B3 for showing their dependency on C, D, E, and F, and P and Q, these 2 jobs are only the predecessor job for E and F, that is respectively, and that is why we place them accordingly and directly connecting them to the E. But in this case, as per the previous rule we have discussed, you can see for C and D the only 2 predecessors are there, and that is A and B, that is common to them. So, we can replace A2, A3, B1, B2 with a common joining point from which the C and D can be coming out. So, let us see how we are solving this one, or reducing the number of dummies. So, you can see the A2, B1, these 2 dummies are placed to bring the A and B as the predecessors for this particular node from which the C and D jobs are initiating. So, C and D jobs are now able to show that their predecessors A and B can be well defined in this condition. The rest for A1 and B3 are required to be kept because the P and Q points are already available here. Otherwise, if this P job and Q job were not available there, then we could have started the F point directly from this place instead of removing this dummy. So, that means you can see the job C and D have common predecessors, that is A and B, which are the predecessors to other jobs as well. So, C and D can be joined at a same initial node shown in the figure here, so that from which the C and D can come out or can be initiated. So, let us see what are the, I hope you are able to understand this one. Now, let us see what is the rule 4. Rule 4 is telling, if 2 or more jobs have identical sets of successors, the latter having other predecessors as well, then the two can be joined together in their final node and connected by dummy jobs to their successors. So, that means if there are two jobs commonly becoming the predecessors of some job, and there are no other jobs dependent on them individually, in those cases we can allow the two jobs to come at a same point from which the jobs can be initiated, dummy jobs can be initiated to show the dependency of them on the other successive jobs. So, I can give you one example. Suppose you consider of a television. Okay. In television, suppose you need to have a screen, LCD screen, which needs to be attached to a power source. So, that means, say this is the LCD screen which is manufactured and a power source is attached to them. So, LCD screen, this is the LCD screen manufactured, which is the job A. This is the power point or power board for this is manufactured, which is activity B. But after that onward, when it is required, both will be joined together and that has to be used together. So, that means dependency of A and B has to come in a certain point. From that onward, it will be used for a number of purposes. So, the dependency of these are essentially required side by side, so that they will be joined together, then only that can be useful. So, in this type of cases, what we do? We go for this activity A and activity B, which are the predecessors of C and D, along with C and D, along with A B predecessors, they are having other predecessors of say P and Q respectively. So, that means, in this case if you draw the predecessors table A, B, C, D, if you look into this, then A has none, B has none, C and is having A, B and P, and D is having A, B and Q. So, in this case what will happen? The A, B are the common predecessors always for all the activities for which it is required. So, we are combining A and B at this point and we allow C to have the combined precedence through this dummy of A and B and the precedence of this one P jobs also, and D is having the combined precedence of A and B through this dummy and the along with that the precedence of Q also. So, basically in rule 4, while the jobs are connected together and for all further activities that jobs needs those jobs needs to be fulfilled together, in those cases we combinedly join those jobs as the predecessors of the all the other successive jobs. So, this is basically the rule 4. Now, let us look into the rule 5, which says the dummy jobs which show predecessors relation already implied by other jobs, dummy or regular, can be removed as the redundant. So, the new term has come which is called redundant. So, if you see in this particular activities where A, B, C, I think this one is another one, D, and say this one is E. So, all these A, B, C, D, E jobs are there, where as per the table it is given to us that A is having predecessors none, B is having predecessors A, C is having predecessors B, D is having predecessors C, and E is having predecessors D and A. So, as per this given format, we have tried to compute this one and to give the dependency of A to the successive job E, which is not the immediate successor of A, but the distant successor of E, we provide a dummy job A1 at this position. So, this dummy job A1 is provided only to construct the network as per the given table is provided in the problem. But if you look into this in some other way, you can see for job B we need A has to be completed beforehand. For starting the job C, we need the completion of B beforehand, which in turn required the completion of job A beforehand. So, that means whether I am mentioning or not, the job C can only be initiated if the job A is already complete. Similarly, the job E can only be started if the job A is complete, because on which the B, C, D etc. are dependent. So, E can be started only if the job A is already complete, and in that case whether I am mentioning that E is a predecessor of E or not, A must be already covered before the starting of E. That means, if we look into this in some other way, say A is the immediate predecessors of B and B is the immediate successor of A. Similarly, B is the immediate predecessors of C and C is the immediate successors of B, but in other way A is the distant predecessors of C and C is the distant successors of the A. So, basically the precedence and succeedence are of two types, one is the immediate predecessors and another is the distant predecessors, and in other ways other term there is immediate successors and there is distant successors. So, if you see into this, you will find out, say for job H in this example, having the immediate predecessors of F and G, and M, the H is the immediate predecessors, but F and G are the distant predecessors. So, basically if I am mentioning A, I am mentioning A as the immediate predecessors of D, it is also the distant predecessors of D. So, that is why mentioning A as the immediate predecessors has no meaning, but unnecessary if we are mentioning it, then the while we are mapping the computer program, the computer will be camouflaged. So, that is why unnecessary, it takes longer time for the analysis, it also may arrive at a difficult condition. So, redundancy often shows up, that is this phenomena is called redundancy, and redundancy often shows up in a network not just in connection with the dummy jobs. It does not cause any problem as far the logic is concerned, but it makes network complicated, add extra dummy variables, and in other term it also takes longer time for the solving of the network. So, redundancy if exists among the predecessor set of any job, one of the jobs is a predecessor of some other jobs in the same set. So, we have to remove the redundancy, that is the essential requirement while we are carrying out the network analysis. So, this is another example of the redundancy is shown here, where it is shown that the M has the predecessors F, G and H. M has the predecessors of F, G and H. F, G are also predecessors of H, which we have already discussed. So, we can come out with a network like this instead of having a constructed network like this. So, this is better for us not to go for this one, because putting these two arrows showing the dependency of M on F and G is of no use. So, now let us look into the method of removal of redundancies. So, to remove this redundancy, let us construct a table where we remove the redundancy. So, what is the requirement is that the table will be prepared in this manner, where all the number of jobs are mentioned at this point, say A, B, C, D, N. Similarly, the dependencies are possible for all the jobs, to all the jobs are mentioned in the column in this side. So, it is again A, B, C, D, E, and for up to N we will formulate it. So, it is basically N by N table where we will mark the dependency in each and every box. So, that means, say if A does not have any predecessors, we will not provide anything in this, we will leave all the boxes blank. Okay, let us prepare the box like this. So, we will leave all these point boxes blank, but suppose B is having A as its immediate predecessors, we will mark a cross on A and say for rest it is not mentioned. Suppose C we are marking as the mentioned B is the immediate predecessor. So, we will mark an X on the B as the immediate predecessors of C, and nothing is mentioned at this point, but as B is the immediate predecessors of C and B is having the predecessor of A, that means A is becoming the distant predecessors of C, as B is dependent on the A. So, A is the distant predecessors of C and we will mark a circle in this box. So, basically by this way we are able to mentioning the cross for the immediate predecessors and circle for the distant predecessors. So, by this way if we try to mention this one, suppose it is mentioned as that D is having immediate predecessors, A is having none, B is having A, C is having D, C is having B, and say it is mentioned D is having C and A. So, what will happen? As per the mentioned table, we are placing a cross for D as C and as well as A, and then we go for trying to search out who are the distant predecessors of C. So, let us see who is the immediate predecessors of C. It is mentioned immediate predecessors of C is B. So, we will make a circle at B because B is the distant predecessors of D. Now, after getting this B as the distant predecessors of D, let us check who are the predecessors of B. So, looking at this we have found the predecessors of B is A. So, we will mark a circle at A because A is now becoming the distant predecessors of D. So, you can see there is a point A where we are having cross and circle together. So, that means which as per the table we are saying that this is the immediate predecessors, that is actually our distant predecessors also. So, it is not worthy at all to mention a distant predecessors as the immediate predecessors, though it is understood the which is the result of the A, that is essentially required in the D, but the time requirement of manufacturing that one is already taken into the network in the first point as the job A is already there. So, the distant activity, distant predecessors is already complete as A, and that is why it cannot be mentioned as the immediate predecessors here. So, we have to remove A from the table as the immediate predecessors of D. So, this is the way we are basically removing the redundancy in a network. So, the same is now showing here for the given example. You can see A does not have any predecessors, B is having A, C is having A, D is having B and C, E is having B and D, F is having C and D, and G is having B, D, E, F. So, all the immediate predecessors are mentioned here, B as A, C as A, D as B and C, E as B and D, and G as this is E as B and D, F as C and D, and G as B, D, E, F. Now, let us see place the distant predecessors of this. So, after placing the distant predecessors, you can see when we place it for D, we have got a distant predecessors A here. When we are placing it for E, we have found the distant predecessors A, B and C are mentioned, and you can see the B at this point is mentioned as the immediate and distant both the predecessors. So, in the previous table as we have carried out, this B can be removed as the immediate predecessors from job E. Similarly, we have got for job F, where C is coming actually for both immediate and distant predecessors. So, no C can be required as the immediate predecessors. For job G, similarly you can see the B and D are mentioned here as the immediate and distant predecessors both. So, we do not need B and D here. So, if you look into the table now, you can find out in this we have to remove B from here, we have to remove C from here, and we have to remove B and D from here. So, that the new table will be AA, BC, DD and EF, and accordingly we can construct the network. So, I hope you are now able to understand how to remove the redundancy. You can have your own terminology, but this circle and cross is a very good option for carrying out this one. There is another problem may arise if the redundancy leads to a cycle. Cycle means if it is shown that job A is depending is having a successors of job B, then job C is mentioned as the successor of B, then say job D is there, which is mentioned successors of C, but A is mentioned as the predecessors of D. So, what is happened if A is mentioned that A needs a predecessors D and D needs a predecessors C, which in turn is having distant predecessors A, then it creates a cycle condition. So, this cycle condition if it is arises, this is impossible to solve. So, in this type of case it is essentially required, or the constructor of the network must be very careful to check whether any cycle is existing in the network path or not. If it is existing, then all the dependencies has to be redefined and the cycle must be removed prior to the analysis of the network. So, I hope this is the way we can remove the dependency of the dummy on the dummy jobs. We can remove the redundancy and we can take care of the cycle situation which can be arised in the network analysis. So, I expect that now you are able to practice the construction of network more for the more critical cases. You use more number of activities for the construction of the network and find out the dummy jobs, search out for the removal of the redundancy, search out for the cases where the cycle condition may arises. Thank you.